Day 32, page 759, problem number 20. This is a vector problem, a three-dimensional space problem where we have two vectors that we're going to try to draw as arrows if we can, or as X's and dots, depending on how this lays out. And we'll need to add our two vectors to get our final result. But we're going to be using the basic magnetic field around a wire equation once again. Here are two wires that are laying, like, say, flat on a table. They're insulated from each other, so they're not short-circuited, but they're in the same plane. Let's use our right-hand rule to figure out, let's say this wire is here. If the current is going up to the left, that means above that wire you have magnetic field going into the page, and below the wire you have magnetic field coming out of the page within the plane of your page or your tabletop. So to signify that or symbolize that at point P, for that wire at point P, you would have magnetic field coming towards the ceiling at that particular spot at point P. And we can calculate that. Actually, let's see if it's not just going to cancel, because both wires have the same current. In fact, yeah, same current, and you're going to be the same distance from both wires. So if with this second wire, with the current going down, that will end up with a magnetic field into the page. They're going to cancel out if the currents are the same. So we don't really need to do any calculation. B total is going to be 0 in this case. But let me just give you another scenario, which they're going to cancel out. But what if the current was reversed in one of these wires, where, say, the second wire there, the blue wire, had current going in the other direction? Then we would have had both magnetic fields going towards the ceiling. So in that case, we would have had to calculate B. And the difficulty or the challenge here would have been, how far away are you from the wire? You're 1 meter from the crossover point, but you're not 1 meter from each wire. You've got to take the perpendicular distance. So if you had to do that particular problem, you can use either wire because it's a symmetrical situation. But if you just draw your basic geometrical triangle, let's use black. If I draw perpendicular to the wire like that and look at this triangle right here, I'm looking at, I'm going to call it, well, I'll call it R because that's what it is in the equation. R is how far you are from the wire to the point of calculation here. And since we know it's 30 degrees, that's a 30-degree angle. Bottom line is, well, since it's a 30, 60, 90 triangle, we can take the shortcut. We have the hypotenuse of 1 meter, so R would be half of that, 50 centimeters. So that would be your distance. You could plug that in for R, 0.50 meters. You have the current, 3 amps, and you know the constant. You would figure out B sub 1, which would be then doubled, because B sub 2 would be the same value, your same distance from both wires, and then the sum total of those two numbers would be the net magnetic field toward the ceiling if we had the scenario like I just proposed to you with the current in that second wire going up and to the right.